Welcome everybody. It's fantastic to see such a welcome group of people to hear Professor Mark Howden speak tonight. I'd like to introduce Professor Mark Howden to you. Since 1991, he has been a contributor to the United Nations Intergovernmental Panel for Climate Change. He's also the director of the Climate Change Institute at the Australian National University in Canberra. Over the last 30 years, he has been involved and worked on climate variability, climate change and innovations with industry, with community and with policy groups as well. He's also, both at national and international level, worked to develop with others an inventory of the greenhouse emissions and also sustainable ways to reduce emissions. And in 2007, he shared the Nobel Peace Prize with other long-term contributors to the IPPC. We have someone that is well worth listening to tonight. Please welcome Professor Mark Howden.
Thanks very much, Penny, for that introduction, and thanks, Ian, for the invitation to come here tonight. It's much appreciated. So what I'm just going to do is just give a pretty quick rundown on essentially the basics of climate change, with a few linkages to what it might mean in terms of future changes and particularly for rural and regional settings. So I'm sort of trying to address the sort of signpost up there, the sort of opportunity, risk, success sort of elements within climate change. So just to go back to in essence, the core of the issue is greenhouse gas emissions that humans are producing. And so the biggest of those is carbon dioxide, and this graph shows the increase in carbon dioxide emissions from fossil fuel use and industry use going back to about 1990. This is produced by the Global Carbon Project, and which is actually located in Canberra. And if you look back at this graph, is that sitting at about 1990, we produced globally about 22 billion tonnes of carbon dioxide. We're now producing close to 40 billion tonnes of carbon dioxide per year, and that's gone up, as you can see, pretty much exponentially. The little glitch here was the global financial crisis. So the thing that threw such a frenzy into our stock markets and things virtually had no impact on greenhouse gas emissions, on carbon dioxide emissions. It just sort of had a little bit of a wobbly and then picked up again and moved on. A little bit of a flattening out here with fracking in the US and some renewables coming into different systems. But in the last few years, it's kept on going upwards. And last year was 2.7% increase globally. This year in 2019, the projections are that we'll be higher than that. So rather than actually going, starting to reduce our emissions and achieve the Paris Agreement goals, in fact, we're heading the wrong way. We're going up rather than down. And the reason why that's important is if for every tonne of this 40 billion tonnes, for every tonne of that carbon dioxide, roughly speaking, about a quarter gets absorbed by the oceans, a quarter gets absorbed by the land, that's trees, grass and soils, and half of it sits in the atmosphere. And that has a residence time in the atmosphere of roughly 200 years. And so for every tonne, roughly, of emissions, about half a tonne of that sits in the atmosphere, and it builds up and up and up and up and up. And within human lifespans, it just doesn't come down from the atmosphere unless we take action to do that. And so the challenge for us is that to stabilise climate change, it's not about going horizontal here and keeping emissions at 40 billion tonnes. The challenge is to go from 40 billion tonnes down to zero. And so that's the challenge that's ahead of us, because, as I say, every time we produce one of these tonnes of carbon dioxide, it's not just a temporary thing, it's a very long-term thing, and it builds on last year's emissions and the years before and the years before that. And so we've got some real big challenges there in terms of going away from where we are, which is that addiction to fossil fuels, to where we want to be in terms of climate change, which is keeping a cap on it. And of course, Australia's part of this picture. So our emissions keep on going up as well. So last year, the last calendar year, we went up about 2%, and then it wobbles up and down with quarterly results. But the reason why we know there's such a strong linkage comes from many different sources of information, so we can actually measure the effect of carbon dioxide and other greenhouse gases like methane and nitrous oxide in the atmosphere, so we can measure the impact of that on the radiation budget of the Earth. But we can also look at the really long-term history of the Earth, in this case via a ice core, the longest ice core, going back about 800,000 years. And this measures, you can extract the little bubbles in the ice and extract the carbon dioxide in those bubbles and measure the carbon dioxide concentration and measure many other things at the same time. But in terms of carbon dioxide, is that each of these little ups and downs is a glaciation, that's the downs, and the little ups is the interglacials, the warm periods between glacial periods. And you can see that over many glaciations and interglacials is that the natural variation of carbon dioxide is actually quite constrained. So it has a bottom, which is around about 180 parts per million, and has a top, which is about 280 parts per million. And that's the natural variation of carbon dioxide in the atmosphere, and that leads to global warming or global cooling, depending on if it's up or down. And you can see that that's actually quite constrained. Humans have been around for about 200,000 years, so that's our latest genetics. So pretty much we evolved. So this is the part of the record that humans have been around, and you can see for a long time we did nothing until the Industrial Revolution, and we've pumped out greenhouse gases ever since. And we can see that we're already at 415 parts per million. So if nothing else from this graph that you take, it's if someone says to you that it's all happened before, it's all within the bounds of natural variation, your bullshit detector should go off big time, because it is not within the bounds of natural variation. Natural variation is from here to here, okay? And we're already here, and we're going up here. This is where we're heading at the moment with our greenhouse gas emissions. And so really good test of whether someone's being straight with you is if they run that natural variability argument. As soon as they run that, you actually should be really alert for more rubbish coming your way. Now, given that we've actually known for a long time about that link between climate and carbon dioxide concentration, so this goes back a long way. So in 1842, that's 1842, this was first worked out by a French guy. And in 1850s, that was first measured by a guy in England who actually I think was Welsh, but that's a different story again. And the English like to claim it. But then in the 1890s, it was first modelled. So if we kept on producing greenhouse gas emissions, how much would the globe warm? So like this goes back a long way, and everything since then just confirms our analysis that if we keep on producing greenhouse gas emissions, we will continue to warm the Earth. The science to do with that is incredibly solid. And so when people start to sort of question that linkage between greenhouse gas emissions and warming trends within the Earth, you're actually dealing with 150 years of evidence. And you've got people who just have a brain fart and think that they can back that up against 150 years of massive amounts of science and massive amounts of evidence is quite ridiculous, but that's how our politics are playing out at the moment. So given that we've known that linkage for a long, long time, and given that we've been producing lots and lots of greenhouse gas emissions for a long, long time, is that it's not surprising we've seen the Earth warm. And so going back to 1850, so sorry, I'll point these things out for the people at the back of the room, but going back to 1850 up to the 2050 up here, so out in the future, we can see what the different components of natural versus human warming have been. So this is our best estimates, in this case, of the natural influences on climate change, and you can see effectively that's flatlining, so it's not going particularly up or down. So left to its own devices, that's what the Earth would have done. That's our best estimate. And you can see there's some little blips in this, so the little dips here is where you get a big volcano. And so those volcanoes spew out particulates into the upper atmosphere, which are often reflective, and they bounce the sunlight out back into space, and so it never comes down to the Earth and never warms us. And so as those particulates filter down and settle down in the atmosphere, that cooling effect diminishes, and you get it coming back to where it would have otherwise been in terms of the temperature. So those volcanoes are very temporary in their influence. In contrast is that the human influence, which is this orange curve, is as we've produced more greenhouse gases, the best estimate is that we've warmed the Earth When we add the natural and the human, we get to the red line, which is so our best estimate of total temperature variation. And the little squiggly line at the back is the measured change within the Earth system, so what the temperatures we've actually measured in terms of the Earth. And you can see that that red line, which combines the natural and the human influences, very closely matches the observed changes across the globe. And so when we start looking at that, we can see that humans effectively have pushed up temperatures by about 1 degree across the globe. That's unevenly spread, so the land has warmed up a lot quicker than the ocean, so the land has already warmed up about 1.5 degrees. If we keep on going the same way as we are, we'll hit 1.5, which is the lower Paris Agreement target, by about 2040, and maybe as soon as 2026, depending what happens in the Pacific Ocean and the sort of interdecadal Pacific oscillation there. And so things are changing pretty quickly, and you can see this divergence between the natural and the human really growing very, very quickly over past decades, recent decades, as we've pumped out more and more greenhouse gases from the atmosphere. And to put that in context, a lot of people think, oh, 1 degree doesn't matter too much. But the difference between our historical temperatures and the last ice age was about 5 to 6 degrees Celsius. So 5 or 6 degrees is like an ice age. 1 degree is a fifth of the ice age, but in the opposite direction. And to put that in context, 5 or 6 degrees delivers you 2 kilometres of ice over Europe and North America. It delivers sea levels which are 120, that's 120 metres below what we're experiencing now. So fundamentally, 5 or 6 degrees changes the face of the Earth. Not marginally, but fundamentally changes the face of the Earth. And that's where we're heading, but in the opposite direction. Like it's an ice age, but in reverse sort of thing. So these are really non-trivial changes in terms of the Earth. And this picture, which comes from NASA, this is just the temperature anomalies. That's the temperature difference from the long-term average for last year. Just shows that it is global warming. Apart from a little patch around sort of Greenland, where you've got lots of fresh water melting and going into the oceans and sitting there, cold fresh water sitting on the oceans, everywhere else is warming. And so it is truly global warming. There is no escape from that. And a lot of the focus tends to be on the averages, so average temperature going up 1 degree, and that's bad enough, you know, given 1 degree is like a fifth of an ice age. But the thing that I'm going to show here is why that's only a really small part of the story that we should be worried about, and particularly here in Australia. And that's to do with variability, climate variability and climate risk. And this is a graph produced by a guy in Finland called Antti Lipponen. So I'm just using his graph, but I think it's a really great way of demonstrating this. So what this shows is that every one of these little dots, sorry, they're probably hard to see at the back of the room, but every one of these little dots here is a location on the Earth. And the dark line here is the equator, so the dots to the upwards from that are towards the North Pole, dots downwards are towards the South Pole, so they're aligned latitudinally. The colour coding corresponds with the temperature, so you've got some dots here which were 2 degrees colder than their long-term average. And in 1900, which is the start of this animation I'll show you, you had some places which were about 2 degrees hotter than the long-term average. So the range between the sort of really coldest places being experienced and the hottest places was by and large, you know, just something like around about 3 degrees. So that was the temperature range which was experienced a bit over 100 years ago. And you can see this here is just simply the sum of all of those different anomalies underneath. And so it produces a single probability distribution which shows that the average temperature, or the most frequent temperature, was pretty much smack bang on the long-term average. But there were some places colder, some places hotter. So if you just look at this as it goes through the animation, so this goes year by year through that 118 years that's on this record, and you can just see how things change. I call this the wobbling jellyfish graph for this reason. So not only, what this shows is not only has the sort of the global warming thing, everything being pushed out to this side of the graph happened, and so you've got this big lump the most frequent sort of temperatures have gone up, so up around about 0.5 degree. But the thing that I really note from this is that we've actually now got a whole bunch of places which are 3 degrees and more colder than the long-term average. We've got a whole bunch of places which are 5 degrees or more hotter than the long-term average. And so that range from the coldest place on Earth to the hottest place, compared with their long-term average, has gone from 3 degrees up to about 8 degrees. So the variability, the risk associated with climate change is more than doubled in that time frame. So it's not just the averages moving, it's that massive expansion, the blowing out of the climate risk, which I think is a really important story and which doesn't get told very often. And we know in Australia that climate risk is what drives us, the drought we're experiencing at the moment, the low flows in the Murray-Darling, etc. And so it's not the averages which matter, it's the risk, it's the extremes which really matter. Now just a couple of slides sort of illustrating a few points from the last IPCC, second last IPCC, it was the land report. Just bringing out a few sort of elements that are happening globally, but also happening regionally in Australia. So one of the things that's happening globally is we're seeing increased duration and intensity of heat waves. So whether this is Japan or Bangladesh or Europe or America, it's pretty much happening globally as well as here in Australia. So we're seeing heat waves of unprecedented extremes. So really hot conditions, but also extended conditions. And so we're seeing that globally. We're also seeing changes in droughts. So droughts in many parts, but not all parts of the world, are increasing in terms of their severity. And so this is one of the graphs looking at drought trends. And you can see in Southeast Australia, we're one part of the red zone where the droughts have got worse. But we're not the only ones. There's big slabs of Africa and other parts of the world, East Asia, where that's happening as well. And so what we're seeing in many places is a combination of changes in rainfall and higher temperatures which are accelerating drought conditions. So places go into drought earlier, they're staying in drought longer, and the drought is more severe when it's happening. And that's pretty consistent across the globe. We're seeing increases in heavy precipitation events. So even though in many places like where we are here, on average the rainfall's gone down, is that when it rains, it's much more intense. So what's actually happening here is as the temperature of the air increases, so as the air warms, it can hold exponentially more water. So hotter air holds a lot more water than cooler air. And if you think of it like a bucket in the atmosphere, so if you've got a bigger bucket which is growing exponentially bigger as the temperature increases, it takes a lot more water to fill up the bucket before it rains, and when it rains and you tip the bucket, there's a lot more coming out of that bucket, so you get a much more intense rainfall. So the duration between rainfall events is extending, but when it rains it dumps much harder. And as a result, we're seeing increased erosion risk, which of course influences farmers, but also water quality, and flood risk in many places. And so those more intense rainfall events lead to much peakier floods and more damaging floods. We've also seen increase in dust storms, including here in Australia, combination of land management, land systems being pushed beyond their limits in association with drought often, but also changes in wind fields. And so some places have got less windy, some places have got more windy, and it's the windier places that are getting hit by more dust storms. And we've also seen shifts in climate zones. So as I'll show in a few slides, in Australia, essentially everything's moved south and pushed out towards the coast. So the dry centre is being pushed out towards the coast. And that's happening in other places as well. In terms of sort of climate stats, so this is from the Bureau of Met website. This is the temperatures across the Murray-Darling Basin, just sitting on the edges here. And if we're looking at the long-term average, their long-term average is different from the previous long-term average. So the Bureau of Met uses 1961 to 1990 as their baseline, their long-term average. If you want to get it to the previous graphs that I showed, which are the pre-industrial, you add 0.4 to this, roughly speaking. And so when it shows, last year was 1.5 degrees, above the average, add another 0.4 to that, and so we're 1.9 above the pre-industrial average, roughly. And so you can see that there's been this long-term trend, particularly from the 50s onwards, to warming, and it just keeps on going up and up And of course there's variability. We'll always have variability in Australia, but you can see the trend is really strong. And that trend has impacts on systems, not often to an extent that we don't recognise in our day-to-day lives. So this are a couple of graphs of temperature increases. So this is seasonally average temperatures on water-limited wheat yields. And this particular example was done for Wagga, west of here. And what this shows is, say if you have a temperature of, say, 17 degrees during the whole crop growth period, so from April through to maybe October, you might get, in a good year, about 6 tonnes per hectare. You increase the temperature just by about 3 or 4 degrees, and you actually halve your yields. So it doesn't sound like much change in temperature, but it has a huge impact in terms of yields. And if you're just looking for the temperature average before anthesis, before the flowering period, you see an even steeper curve. So it goes from full yields at 16 degrees to half your yields at 18 degrees. So just a 2 degree increase halves your yields, assuming that your system is being run on a fairly constant basis, so you're not adapting wheat varieties, etc. So you can see that what sounds like relatively small temperature increases can make a big difference in terms of productive systems. And then there's the question about, well, can I get away from this? And this is again a Bureau of Met graph. And what this shows is the area of the Murray-Darling Basin in this case, which is affected by the top 10% of temperatures. So it's an extremely hot year, at least what we would have thought of in the past as an extremely hot year. So if it's sitting at 0, so nowhere in the basin experienced a really hot year. So these are the different years across here. But what you can see is that over the last decades, and particularly the last few years, effectively everywhere in the basin is experiencing what used to have been thought of as an extremely hot year. So the abnormal has become normal, and it's everywhere. So there is no escape. There is nowhere you can go in the Murray-Darling Basin and not experience, in any standard year, something which would have been thought of as an extremely hot conditions in the past, and when your parents or their parents were alive. And so these are pretty profound changes, that this is just so pervasive and so significant. And so the concerns that people have in the community, I think, are warranted in relation to climate change. But again, most of the focus tends to be on the high end of the temperatures, the heat waves and hot conditions. And it's not just that that's changing, as I showed you in that wobbling jellyfish graph. Yes, the hot temperatures are expanding, but so are the cold temperatures in some places. And unfortunately, Southeast Australia is one of those places. So what this shows, this is work from my colleague Steve Crimp, and this shows essentially it's a frost risk graph, again for Wagga. And what this shows is on this axis the temperature, so 2 degrees is a light frost, -2 is a heavy frost, and what this shows is day of year, so late frosts are killer frosts in most of our systems. And this shows the middle of the year through to the end of October or thereabouts. And so this little triangle sort of indicates the frost risk in 1950. So that was the sort of thing. So you wouldn't get anything past a light frost, anything past sort of August in those circumstances, in that place. But I'll just leaf through decade by decade what changes in terms of frost risk in this location. So that's the 1950s, this is 1960s, 1970s, 1980s, 1990s, year 2000. This is the noughties. And you can see just that progressive increase in frost risk that our farmers are experiencing. And so that message is that it's not just the hot end which is getting worse, but it's also in some places the cold end that's getting worse. Our range of extremes is actually increasing. The difficulty of managing those extremes is increasing. And so we need to be thinking, this isn't global warming, this is climate change. It's not just the warming component. And of course, a really critical part of the whole picture is what's happening to our rainfall. And so again, Bureau of Met, autumn rainfall in this case across the Murray-Darling. And this is blurred because the picture in the northern part of the basin is different from this part of the basin. But basically, right across the basin, on average, your autumn rainfall is declining. And so you've lost about 20% of your rainfall on average. Lots of noise, but there's a long-term decline there. And we understand why that's happening, because it's to do with the high-pressure system. So the intensification and change in location of the high-pressure systems, the subtropical ridge, if you're a climatologist. And so temperatures are changing, extremes are changing, and that rainfall is changing. And as I mentioned before, that's sort of changing the seasonality and location of rainfall patterns across Australia. So this is work from David Stevens in West Australia. And this is the historical picture of seasonality of rainfall. So summer dominated across the top half of Australia, and then as you come down to the south, more Mediterranean style. So wet, cool winters, hot, dry summers. And so this is the historical pattern, and this is the pattern over the last 15 years or so. And you can see that pattern of this, tropics moving south and the arid zones pushing towards the coast. And so quite significant sort of changes that we've seen in terms of rainfall, seasonality patterns. And that not only impacts on agriculture, but things like water. So cool season rainfall is much more efficient. A millimetre that falls in winter is much more efficient in terms of filling up dams than summer rainfall, which tends to disappear before it ever gets there. And so that change in seasonality has quite important implications for things like water supplies. And that combination of changes in rainfall and changes in temperature are already putting the brakes on agriculture across our broadacre cropping zones in Australia. So this is work from Embers, Neil Hughes, and what they used was agricultural statistics. So this isn't modelled data, this is the ag stats, of farm production. And what they did here was effectively take out the management and technology signal, which has been tending to push yields upwards, and separate that from the climate change signal. And what they found was that climate change signal was consistently downwards. And in some places, like over here and over here, it's like worth 20% of yield. So in the absence of climate change, in those places, yields would have been 20% higher than what we've actually seen. And if you're a farmer and all of a sudden someone says, I'm going to take 20% of your yield away, you'd scream. But this is what climate change is already doing. And that 20% is usually where all your profit is as well. So it's pretty critical. So the next part of the talk, so that was all looking backwards, really. It's saying not sort of looking at a crystal ball in the future. It's actually saying this is what's already happening, and this is the consistency of our understanding, which links everything from greenhouse gas emissions through to climate change, through impacts on key systems. So the next part of it is what may happen in the future. And of course, the future is ours to choose. This is not something which is foreordained. This is our choice, and that's why groups like this have a role in terms of choosing the future that we go on. So this part of the graph is the one that I showed up first. This part, emissions going up from 20 billion tonnes to close to 40 billion tonnes historically. And that should be, okay, that's right. So this is the trend we're on, going up on the red line here. And if we keep on this trend, we end up in a world which, by these assessments, was 3 to 5, maybe 6 degrees warmer. Really important to note that these were based on the previous sort of generation of climate models, and the new generation, what's called CMIP6, actually show a higher sensitivity to greenhouse gas emissions than the CMIP5 model. So what was 3 to 5 degrees will actually probably end up like 4 to 6 degrees or more when those model numbers have been ingested. And so that's the trajectory we're on, and so leading us to an ice age, but in reverse, 5-degree world. If all governments actually did what they said under the Paris Agreement, so met our commitments in Australia, it's 26 to 28% reductions against 2005. If all of the governments did what they say they do, we'd be on this curve. So we'd still be dealing with 3 degrees or thereabouts, plus or minus. If we want to meet the Paris Agreement goals, which is keeping temperature well below 2 degrees is the main goal, and there was an aspirational goal of 1.5, we have to go onto this blue line here, and we have to effectively go net zero by 2070. If we want to go to 1.5, we have to go on the dashed line here, and we go net zero by 2050 or maybe even 2045. And you can see the difference between where we're heading and where we need to go is massive. Now, some people might look at that and be really scared and really concerned, and it is a matter for concern. But other people could look at that and say, what an opportunity. How do I get a slice of this action going from here to here? How can we be part of a global solution that not only improves the globe and takes us away from really bad outcomes, but also makes massive money for people, for companies, for regions. And so I look at this difference here to here. Yeah, it's a challenge, but if we're smart, it can be a fantastic challenge. It can be a fantastic opportunity. Not without its risks and stuff, and not without consequences in terms of the climate changes we're talking about, but preventing them from getting worse, I think is an admirable goal in its own right. And I think we can actually make this work for us. We just have to be a lot smarter than what we are at the moment. So if we go down a pathway which is, letting climate change rip, sort of thing, these are the sorts of things that really worry us. So this is what we call a multi-hazard map from Camilla Mora in Hawaii. And what this shows is for different risk factors like sea levels and storms, global warming and heat stress, water scarcity, pH changes in the oceans, etc. So each of these have their own little hazard map, as it were. And what Camilla's done is add all of those up to get this sort of global map here. And what their assessment is that, well, for starters, you can see that the hotspot really for global impacts is Australia and its near neighbours in this area here, not without impacts, say in Elise's country. So we've got a student here from Mexico, Elise, but our region is going to bear the brunt in many ways of climate change, according to this assessment, in terms of extremes. And their analysis was that something like about 40% of the global population would suffer 3 or more of these extremes per year by the end of the century. So not every now and again, not the 1 in 20, 1 in 50 year event, but 3 in a year of different types. And so the consequences of this in terms of human misery and lives, etc., is potentially massive, and we should be really concerned about that, I think. We also produced in the IPPC a whole stack of what we call burning embers diagrams. And so these are sort of diagrams where we try to convey the idea of risk associated with increases in temperature, so going from 0 to 2 degrees to 5 degrees up on that graph. And we colour code them. So if it's white, it's basically no risk to a particular sector, yellow is some risk, orange quite a bit of risk, red is high risk, and purple is very high risk. And in this particular study, this report, we separated it out into things like water scarcity, soil erosion, vegetation loss, fires, etc. And so what we're trying to do is pull together, aggregate a whole stack of different types of research and different studies into sort of single indicators of risk for critical systems. And so if we look at wildfires, for example, at 1 degree, which is where we are, we see an increasing risk. So we're into the moderate risk level. And by the time we get to 2 degrees, we're into a high risk level. By the time we get to 3 degrees, it's essentially unadaptable in many places on Earth. And so it's what we call very high risk. And interestingly, because I've been engaged in the IPPC for a long time, I've actually seen the evolution of these diagrams. So I was there as part of the team that produced the first one of these back in 2001, and every time we produce these and analyse what we know about the systems, the red bars kept on creeping down these things. So our assessed risk for any given temperature was worse and worse. And then a couple of reports ago, we found that our existing risk categories were not hard enough. They weren't sufficiently concerning. So we added the purple colour, just like we've added the catastrophic fire danger thing to our fire indicators by the roadsides. And so in a sense, the science community has been in catch-up mode, because we've been consistently underestimating risk associated with climate change diagrams. And so we've been doing those sorts of things globally. Coming in more locally to home, this is actually some work on heat stress I did back in 1999, so last century. And so what I did was, in this case, me and my colleagues, we looked at the frequency of heat stress days. So heat stress is a combination of temperature and humidity, where it becomes difficult both for livestock and for humans to operate outside without shade, etc. And if you look at the top end, 70% of heat stress days, 70% of days are heat stress days, and down in this part of the world, it's about 10% or less are heat stress days. If we look at a world that's 2.7 degrees warmer, so that's where we're heading or perhaps slightly lower than where we're heading with the current Paris Agreement commitments. And you can see that right across the top end, so if you're actually in the top end, every day becomes a heat stress day. And right across the top third of Australia, you're experiencing really torrid conditions across 3/4 of the year or more. And the sorts of conditions we'd experience down in this part of the world are the sort of conditions that have historically been experienced in places like Townsville and Rockhampton up on the Queensland coast. So that's the sort of changes that we're likely to experience with what sound like relatively modest temperature increases. And that has, again, profound implications for everything from productive activities outside to sport. If we look at precipitation, so this is again an IPPC graph. So precipitation change across the globe. Basically, it's a picture of 3 zones. So we've got the equatorial zones, which are likely to get very much wetter, and so often they've already got a lot of rainfall, and most of that extra rainfall falls over the oceans, so it's not helping agriculture, etc. We've got the mid-latitudes in both the southern hemisphere, but also the northern hemisphere, which are likely to get a lot drier, and then we've got the polar regions, which are likely to get wetter again. And unfortunately, Australia is smack bang in the middle of one of those dry zones. But we're not alone. So if you go across to Chile, they've got droughts which are every bit as bad as ours, perhaps even more extended than ours. If you go to southern Europe, is that they've got really bad droughts there. If you go to California, they've got really bad droughts there as well. And so we're not the only ones suffering. I'm not sure that helps, but sort of as part of that global picture of what's going on. And of course, if you get hotter conditions plus less rainfall, it's not surprising that we actually see less water into our streams and into our dams, and that's what this graph shows, which is again an IPPC graph. This comes from the last assessment report, and what this shows is percent reduction in runoff. So this is dealing with the means, not the variability, just the average percent reduction in runoff per degree Celsius, remembering we're already 1 degree above the long-term average. So in this part of the world, it's about 10% per degree. If you go over to the west, it's 1/4 of your water per degree. And this is what we call the median estimate. So across all of the range of different results from the different models and things, this is the sort of the middle part of that range. So doesn't look too good, and you'd be thinking, well, we're sort of almost in that scenario at the moment. If we look at the best scenario, that's the positive slice of the results, is that significant parts of Australia may get more rainfall, but there's parts of Australia, like here, and down Western Victoria, where even the best scenario, the wettest scenario, is actually drying. Where even under the best conditions, you're still going backwards. And if you look at the worst case scenario, it's grim everywhere. And so in this part of the world, we're probably dealing with 15% per degree. And you might think, oh, this is an extreme sort of result. This isn't representative. It's unlikely to happen. But if you actually look at what's happening over in this part of the world, Perth's dams have already lost 85% of their inflows at 1 degree. So if anything, there's a real risk that these are underestimates of the change rather than overestimates of the change. And so the implications for things like the Murray-Darling Basin are profound. And ignoring climate change in terms of the Murray-Darling Basin Plan, to me, makes absolutely no sense. And it's ignoring one of the most significant changes that's likely to happen over the next few decades. So if we think we've got challenges in terms of competing demands for water in the MDB, to date, we ain't seen nothing yet. The battles in terms of environment versus agriculture versus urban usage, they're just starting now. And so this would be a really significant area, I think, in the next few decades. Now, just the last couple of slides here. This one is this comes work from Scott Power from the Bureau of Meteorology. And what this shows is what he calls the disruption from the ENSO factor. So has everyone heard of El Nino and La Nina? So El Nino in this part of the world tends to drag rainfall down. Not all El Nino years are drought years, but you increase your probability. And La Nina's push the rainfall up, and not all wet years are La Nina years as well. So it's a probabilistic thing. But what he assessed was, what's that variability associated with El Nino, and how does it change from pre-industrial to 20th century to more recent, and how does it change in the future out here? And his assessment was, if we go to a low emission scenario, firstly is that climate change has already increased the variability associated with ENSO. So we're already getting increased variability in our systems because of ENSO. So the wet years are getting wetter, the dry years are getting drier. Under low emission scenarios, that keeps on going up, but tends to tail out. Under high emission scenario, it just keeps on going up and up and up. So that variability just expands out into time. And that's, I think, a really significant concern, because it's that variability which impacts so strongly on production systems, on value chains, reliability of value chains, etc. And just to reinforce that point from another perspective, this is what we call a meta-analysis that I was part of in the last IPCC report. And for years from 2020 up to the end of the century, what we did was we looked at the literature which had changes in the variability of crop production across different parts of the globe. And the message is that variability is relatively modest in the very near future, but as we go towards the end of the century, it explodes, just massively increases in that variability. So the risks associated with starvation and, or excess food in some years are likely to increase massively as we go towards the end of the century. And if we're thinking about things like migration and stability of regions, we really need to think very hard about this. There's various links between the Arab Spring and climate factors. And so climate was driving low food, which drove part of this disruption. And there's some dispute about that, but I think there's at least some component in there. I don't think it was the only thing that's going on. But when you actually look at this sort of picture, that starts to, I think, come into much clearer focus. And we do need to take climate change into very serious account in terms of our security thinking. So the last few slides are on adaptation. So adaptation, and also a few slides on mitigation, I think. So am I still running okay time-wise?
You're okay. Yeah.
Okay. So just like ASIC, our wonderful Securities Investment Commission, who doesn't actually seem to do that much, but it's a great idea. Past performance is not necessarily a reliable indicator of future performance. So whenever you buy some shares, like this is the standard sort of mantra. Just because they've gone up in the past doesn't mean they'll keep on going up, because they could take a dive tomorrow, sort of thing. And if I bought the shares, that would take a dive tomorrow. So just like if I put money on a Melbourne Cup horse, it's doomed. There's just no way it's going to win. But just like with investments, we need to think about that in terms of climate. Just our past climate is no longer necessarily a reliable indicator for our future climate. We've already seen us move past the envelope of previous variation into new territory. And so as we move further into new territory, that past history and that past experience will become less and less relevant in terms of future decision making. So what do we do about that? Well, in a sense, what we do is what we always do. So if we're in agriculture, and this was just an example from agriculture, the fundamental goal of agriculture is matching up your genetics with your management and with your operating environment. That's your climate environment plus your regulatory environment, your financial environment, social environment, changing consumer preferences, etc. And if you don't do that, then you're either going to underperform, so you're going to perform less well than you could otherwise have done, or you'll incur additional risk. You'll be operating in a more risky way. So those are essentially just the two outcomes from not doing that matching. And as the climate changes, we need to match that climate. We need to track that climate as it changes, not 10 or 15 years to, looking in the rearview mirror, but as it changes, we need to be managing that change. And so this is one of the things that I don't think we're doing effectively. And so, not to the extent that we could. And so when I talk about climate adaptation, which is responding to that change, which is making those changes as the climate changes, essentially the common sort of version, the common language version that I created, was just changing what we do to get what we want. And so for me, adaptation and climate change is fundamentally about human values. It's not about the science or climate, it's fundamentally about how does it impact on things that we value as individuals, as communities, as nations, as a species. And for me, adaptation is increasingly becoming an important part of climate change. So if you go back a decade or two, it was like the poor cousin of climate science and the mitigation, emission reduction side of things, but I think it's really starting to come into frame now. So the question then is, how do we adapt well? Well, for starters, it's really important to understand that linkage of values and your responses that are open to you or that you want to take into account. So sitting here, this is a picture of a fence line contrast. So that's a fence running down the middle of the picture. As you can see, there's a completely different management strategy on the left versus the right of the fence. So the set of adaptation options that is going to be preferred by this person, this grazier, is going to be different from the set of adaptation options there, because the values of this person are fundamentally different from the values from this person. So the choices of adaptation can vary from centimetres by, on a scale of centimetres. One side of the fence, one set, another side of the fence, another. So it's really important to mention this because adaptation is going to be highly contextual. One property, another, one business, another, is going to differ. And it's always going to be driven by the values, what you're trying to achieve in that particular business or property. And that means there's no rights and wrongs. There is no right way of doing this or wrong way of doing this. It's what suits those values. So when we actually start to sort of strip away, once you've got past that stage, we actually find that there's a lot of options for people to adapt to climate change. So some of them are on-farm versus off-farm. Again, this is a rural sort of example because I thought this was the most appropriate here. So you can, on-farm or off-farm adaptation, you can diversify. You can look at short-term or long-term options. You can think about tweaking your existing system, or you can think about changing your system more fundamentally. That's the incremental to transformational change. Or there can be adaptation in terms of institutions or regional change through catchment management arrangements, or across value chains, so looking at your supplier relationships, etc. Almost all of these involve some degree of cost, but all of them are done in the expectation that you're going to be better off. So the only rationale for adapting to climate change or anything else is that you're going to be better off than you would otherwise have been. So adaptation is always a positive thing to do. If you're doing it sensibly, it's always bringing you benefits. And so adaptation is one of the good news stories. I mentioned before, thinking about the big changes in terms of our energy systems, not thinking about that as a negative, but twisting your mind and thinking about it as a positive. And it's the same with adaptation. Don't think about it as a cost, but think about it as a benefit. And the other part of that benefit equation, it's not just about the finances and stuff, but what we find when we actually go and survey farmers and those who are adapting to climate change, who acknowledge climate change and adapting to it, versus those who aren't, those people who are adapting to climate change are empowered about making decisions about their future, and they've got lower stress. They're happier. And those people who are ignoring it and basically not responding are actually basically something in their brain is saying, I'm doing a really dumb thing, and that generates cognitive dissonance. So part of your brain says yes and part says no, and it's like tearing your brain apart, and it's really unpleasant. And so that's where you get stress. And so if you actually acknowledge change and respond to change, you're much, much better off psychologically, as well as probably much better off financially. So there's lots of positives about adaptation. And I don't want to go into any detail about this, but again, this is a summary table from the last IPPC land report. And what this does is it looked at the whole range of literature, about 700 different studies, and categorised those studies in terms of different activities, such as like putting agroforestry on your land, soil compaction here, and then looked at the benefits, whether these were aligned with mitigation activity, that's emission reduction, with adaptation to climate change, with reducing desertification, reducing land degradation, or with food security. And by far the majority of cases, you could find response activities which were aligned with each of those things. So you could actually have activities like increased soil organic carbon content, which give you a tick in every box. And so again, there's that message that if we're smart about these things, we can actually have multiple benefits from effective action. And there's only a couple of boxes here and here where there were significant trade-offs. So I just highlight that in terms of the land management one. And this was specifically about reducing grassland conversion to cropland. So we slow down the conversion of productive grasslands into cropland. And that had a sort of an orange traffic light sort of over here. And that's simply because a hectare of cropland feeds a lot more people than a hectare of grassland. And so if you slow down that conversion, it impacts on food security. And So when we actually look at that in a more sort of local context, this is work from Steve Crimp and Harm Van Rees, etc., down in Victoria, is that they went out and dealt with the same farming community on multiple years. So they started off and then they went back multiple years. And when they first engaged with those farmers, the sorts of things, and said, well, how are you going to respond to climate change? Here's a scenario for you. How are you going to respond? And the first year they came back and it was all agronomic and technical. So it was changing, moving to zero till, changing your rotations, doing soil testing, that sort of stuff. At the end of that process, when they'd gone through all of the different options and things, where the farmers said was really important was all about the strategic decision making. It wasn't about the tactical, it wasn't about the technical, it was all about the strategic decision making. And ultimately, I think this is a really important message. It's not about the detail, it's actually about the big picture and getting that right. And so if we look at potential responses in terms of emission reduction opportunities, so this is reducing our greenhouse gas emissions or pulling down carbon out of the atmosphere, is that if we're to do that, if we're to meet the Paris Agreement goals, we have to change pretty much everything. So our energy systems, our transport systems, our food systems, our waste systems, our industrial systems, etc. Is that all of those contribute significantly to our greenhouse gas emissions profile. And the most likely cost-effective solution is not just choosing one sector like electricity and isolating the rest. It's actually looking for the options right across the spectrum of emission sources. And to do that, we're going to need a whole stack of new tools in the toolbox. New technologies which result in higher efficiency, cleaner energy sources, etc. I actually reckon, and there's other people who think the same way, that there's absolutely massive opportunities here for the nations and companies and communities that actually move fast on this, who are first movers, who actually can be ahead of the pack and attract the interest and investment that takes them forward into that option space. And so just one example is the ACT and our going fully renewable. So we're now 100% renewable in the ACT electricity. And so our emissions profile has just gone like this. So now we're into the really difficult bits, which is transport and home heating and cooling and similar things. But great to actually go from here to here. And we've done it almost no cost. And at the same time, we've attracted all sorts of new technology startups and energy businesses into the ACT. So we're way better off than we would otherwise have been. So there's a win-win in so many different ways from being a first mover. And so some other options are green steel. So we can use hydrogen as a reductant rather than coal as a reductant, so you get away from metallurgical coal use. You can think about renewable hydrogen exports. This is not converting brown coal into hydrogen. That's really dumb. This is about using renewable electricity to generate hydrogen. We've known how to do that for hundreds of years, but not at the scale that's needed here. We can do negative emissions, sucking carbon dioxide from the atmosphere, and there's a whole range of different technologies for that. We can move into lower emissions agriculture, and some of Australia's farmers are probably the best in the world at doing this at the moment, particularly in dry conditions, difficult conditions. We have a whole world of knowledge-based exports, which is just waiting for us to occupy. The speaker, Andrew Blakers, who's coming in February, a great example of potential knowledge-based exports. There's a huge demand for the sorts of knowledge that he and others in Australia have generated, and not just in the science community, but right across the board, policy, industry, practitioners. And so there's just so many opportunities for us if we're smart and if we're on the front foot. And so, as well as that, there's lots of possible win-wins between adaptation, that's responding to climate change, and mitigation, that's reducing the greenhouse gas emissions. So we can see alignment between those different goals in lots of different ways. So the question then is climate change a risk or an opportunity? So I love this picture. You can see one face or you can see the other, and you can choose which face you want to see. And it's just like that. We can choose to see climate change as a really bad thing, as a huge black cloud with very few silver edges around it, or we can actually see this in a positive way and say, okay, well, this is a really big thing. It's unlikely to slow down. It's unlikely to stop. And how do we position ourselves well for that future? And it's a completely different way of thinking. It chooses the choice between this face and that face, and it is our choice. So the question is, is it an impossible squeeze? Is this just too hard to deal with? Lots of people think that. is it consistent with the trajectory we're already on? Well, we've actually got whole companies, Atlassian, etc., who are actually on this trajectory already. So some people are saying, yeah, I can do it. So this is not universal, that it's an impossible squeeze. Instead of saying, having an avoidance strategy, how do we get away from this? How do we bury our heads in the sand? We can say, how do we best deal with it? Or how do we make opportunities out of this? Not in a cynical way or anything like that, but just being realistic about the nature of this beast and actually saying, okay, well, how do we get on the front foot? So that leads me to the last couple of slides, so what is a sensible strategy for a changing climate? So I don't really know the answer to this. This is a very personal question from my perspective, but I do know that I can go into almost any bookshop and I can find meters of bookshelf space on strategic thinking and strategic decision making, and usually it's pretty fluffy and guffy and not stuff that I engage with. So for me, I just sort of created and borrowed from a few other sort of definitions. And for me, this is the guts of a decent strategy. Really simple, the sort of thing you can remember and put as a filter over your decision making. So it's the game you want to play, or sometimes it's the game you don't want to play, and how you think you can win. So if it's not the game you want to play, it's not a good strategy. If you don't think you can win, it's not a good strategy. It's really quite simple when it comes down to it. It's actually about broad scale filters that match up your value with your potential opportunities out into the future. What are your capacities and what's your vision? So if we're going to do that, what do? Do we actually think about the old climate or the new, the one that's emerging, the one I've talked about? Do we think about the old industries and the old ways of doing things or the new? Do we actually think about, in this case again, farming for commodities, like the way we've always done it, canola, wheat, beef, etc.? Or do we actually think about maybe there's different opportunities? Maybe we can think about also being energy farmers, like Charlie Prell. Maybe we can think about being carbon farmers, like putting some trees in the landscape, doing it systematically and sensibly. Maybe we can be thinking about being water farmers. Water is just going to become so more critical a commodity in the future. Or maybe it's about biodiversity. We've already had various biodiversity sort of purchasing arrangements in various state governments, but how about making that systematic and long-term rather than just an experiment? So it's really starting to ask bigger questions about what we're doing here. And so one example of this is Pete Mailer, and Charlie probably knows Pete pretty well by now. And this is perhaps a little simplification of Pete's current situation, but basically this is a quote from Pete going back 6 months or so, is that and the story is Pete up near the New South Wales Queensland border, fourth generation family or fifth generation family, been there a long time, always growing commodities, beef, wheat, etc. And basically Pete said, stuff that, climate change is just making this so hard. So he went into solar farming with his brothers, and so this is the quote, solar farming is better money, safer money, easier money than farming, given climate changes. So this is what we call a transformational change, shifting from producing one commodity, agricultural commodities, into a completely different one, energy. And so Pete's not only done that for his own farm, but his brothers and he have now got this great business of actually selling, low cost, easy, do-it-yourself, essentially, solar farms across different places. And the thing that's holding us back is not the farmers and their preparedness to invest. The thing that's holding us back is the transmission lines and the capacity in those transmission lines. It's the rules of our network which are biased against small to medium-sized operators.
And councils.
Yeah, and that's part of the deal, yeah. And so all of these barriers, and most of them are institutional barriers, which means they can be changed. These are not fixed forever. That they were done there to benefit people. They can be changed to benefit people as well. That's right. But it's also if we want it to. So the last couple of points is just when we're thinking about change, we can focus on the existing systems and tweaking the existing systems, or we can make bigger changes. And there's no rights or wrongs here, and I'm not promoting people make transformational change, but just when we're starting to think about strategic options, instead of just thinking about the way things are, we should think about the way things could be. And it may end up that you go back to this, and for a while you just tweak your existing system, but at least explore that space and open up the option space for yourself. And part of that option space is the policy domain where the lobby is working. And so at the moment, virtually all of the oxygen is being sucked into this picture versus this picture. And it's such a small slice of the action. So our energy emissions as of now are probably about 1/3 of our emissions profile nationally. And yet it occupies about 95% of the political oxygen. And so that 2/3 of the emissions profile is being ignored. And yet there's lots and lots of potential win-win situations in there. The adaptation issues are being almost completely ignored. So if we look at the productivity of the Australian research community in adaptation, it's gone down by over 70%, 70%, in the last several years. So just as our climate is ramping up and the change is happening, we're actually disinvesting in the science that needed to support action. Is this the behaviour of a clever country? No. So anyway, quick summary of what I've just talked about is that massive evidence that the climate is changing, and it's changing due to human activities. Myself, Phil Kokic, Steve Crimp, a few years ago, we did a statistical analysis. There was less than 1 in 100,000 chance that it wasn't humans who were doing this. If we redid that analysis, because that went to 2013 data, if we redid that analysis to 2018 data, it'd probably be less than 1 in 250,000, because things have changed quite quickly since we did that. So the chance that this is not caused by us is effectively zero. So we've got to take responsibility. The best of our assessment is more changes in store. You know, this is a runaway train and it's going to be really hard to stop that. Not impossible, but pretty hard. A lot of our agriculture and rural areas, such as where Goulburn is located, they're already under stress, and climate change is likely to make that harder. It's unfortunate, but that's just the way it is. There's lots of solutions that I tried to paint out that picture, but if we look at whether they're being adopted sufficiently broadly across the globe or sufficiently effectively across the globe, the answer is probably no. So we have a lot of room to move, but we're not moving on it at the moment. And we can invest in those effective options for people that benefit, have win-win-wins right across the board, but we're just not doing it at the moment. And climate adaptation and emission reduction, to the best of my ability to judge, is going to be an increasingly important part of how we think about Australia in the future. Thank you.
There's a question, and I'm sure we have time for some questions.
Sure. Surely one of the biggest drivers is population, but I didn't see the word population once. But if we didn't have so many damn people using so many resources, things would be a lot better, surely.
Well, a lot better is a value judgment, but absolutely, if you do any analysis of things like what's driving emissions, population is a big, not only, but it's a big contributor to that. And so at the moment we've got 7.5 billion people on Earth. When I was born it was just over 3 billion, so we've gone up 150% in my lifetime. If that doesn't scare the shitters out of you, no, nothing will. I mean, that is seriously scary, that we've actually got that many more mouths to feed, that many more bodies to transport around the country, etc. And we're heading to close to 11 million at the moment on current trajectories. It's very hard to see us doing that without massively increasing our footprint on the globe. And probably the best thing we could do in terms of climate change at this point is education for poor people and building up economic status of poor people. And that's because the evidence is that, particularly women, so building the rights of women, reproductive rights, and their capacity to have a say in what happens to them is the best contraceptive. And so I think we need to be thinking about that. And just to add to that, if you go back into history, is that back in Ronald Reagan days, he took apart the US family planning program back at the time when we sold the Telstra and the Heritage Trust times. We stopped our family planning program, so we're part of this. We're actually a contributor to this. We've actually deprived people of those choices which they would have made, which probably would have benefited them and benefited the world. We need to be pretty brutal about this, and it's only just starting to come out in the science literature, discussions about population.
There's a question up there. Yes?
Can I ask, have you made this presentation to any of our ministers or our government? Have you been invited? Is anyone interested? Or the National Press Club?
Well, I
have any councillors here or our local
Mayor Bob Kirk, I invited him formally by letter, and he wrote me back a really nice letter giving his apologies he was unable to attend tonight.
And what about our federal government?
Mr Taylor and Mrs Tuckerman were also formally invited by letter with plenty of notice, and I didn't actually receive a reply from them. But I did write one to the Chamber of Commerce, and I know we have a representative here tonight, so thank you.
So I regularly offer briefings to parliaments, not just one in Canberra, and regularly I get ignored by one particular part of the spectrum, and but taken up by other parties. That's not ubiquitous. So 4 weeks ago I gave a briefing to Suzanne Lay, and I had an hour and 20 minutes with her, which apparently was extraordinary. And so she's the key minister there, and she's heard this. So that's probably as much as I can say at this point. Yeah. But certainly the Greens and Labor Party are well across the issues. They've heard, me rabbit on and other people.
I'm really proud you won the Nobel Prize.
Question down here.
It's sort of a personal question. Do you, for the knowledge and deep understanding of where this is projecting towards a pretty gloomy future, how do you ever get despondent about that, and how do you cope with that, all this knowledge? And but that might be because some of us are feeling despondent.
So I actually wrote my first essay on climate change was when I was in year 11. So I figure that if a year 11 kid in the 70s could actually figure this one out, it's a bit of a worry that it's taken all this time for others to get there. I tend to be a glass half full person, so I tend to approach things in a positive way. Anyway, I like thinking about cooperation. The end picture here, it's actually about how we're stronger together and work with other people to achieve things. And I think it's great when you've actually got people that you can do that with. And I think that's a really positive thing for me as well as others. I have a fundamental, I guess, philosophical view that if you only speak about the negatives, you turn a lot of people off. But you don't want to gild the lily and only speak about the positives. It's actually some sort of balance between concern and hope that you have to have both in your own brain as well as how you communicate with other people. And so that's what I try to do. I sort of try to paint those two different elements, and if you engage with me, I can talk about pathways to deal with both of those things. And so I sort of try to make sure that what I say is internally consistent, with my own sort of personal values, and with the science and with the needs of the people I'm engaging with, and I find that is enough.
We've got a good crowd here tonight.
Any more questions? Yes.
Yeah, you didn't mention some of the serious tipping points. For instance, the melting of the glaciers, the melting of the ice cap, which of course is going to give rise to massive flooding of some of the low-lying areas, of very heavily populated areas like the Mekong Delta and Vietnam, Bangladesh and so on. And I was just wondering whether, how much, because obviously this was all in the IPPC, why this doesn't have a motivating effect on the rest of the people that go to the United Nations meetings when they're supposed to be working towards a common cause.
Yeah. Well, personally, I found what I was presenting was scary enough without going into the really scary scenarios. But a couple of points there. One is that I just seriously had limited time, so there was only so much to cover there. But it's very clear, even from the very first slide when I talked about the effects of carbon dioxide varying on a global scale, those variations are driven by minor variations in the Earth's orbit. And the Earth's orbit only results in a very small change in the radiation that's received by the Earth. But what it does is it triggers off feedbacks which push us into and out of the ice ages. So feedbacks are inherent in our climate system, and the more we muck around with it, the more we change those feedbacks. So apologies if I didn't make that sufficiently clear.
Just to interrupt, some of those are like 100,000 years. You know, the orbit from circular to
Yeah, that's right. Yeah.
Some are 25,000. So we're not in that time scale. We're really tiny.
No, that's
So
right. But I was
tiny
just
one.
sort of saying that yes, feedbacks are part of the bigger sort of picture. And obviously we have personal feedbacks, you know. So if it's a hot day and you turn on your air conditioner and you've got non-renewable, you're actually doing your own personal feedback into climate change, and which just makes it worse. And so these feedbacks happen in all sorts of different ways. The feedbacks that I think are really concerning are those relating to particularly methane hydrates in the oceans and methane in the tundra. So as these warm up, start to release methane. We've started to see some signs of that already. But the best sort of paleo assessment I've seen of at least the methane in the tundra is that it's unlikely to become a major issue if we keep temperatures down to 2 degrees, and may become an issue if we go up to 3 degrees. But after 3 degrees, it does sort of likely to cut in. That's based on paleo data. And generally speaking, I think the analysis where you get people who are really solid science who move away from the hand waving, it's pretty much the same message, is that if we keep temperatures down below 2 degrees or thereabouts, the likelihood of serious feedbacks, uncontrollable feedbacks, is low. So if that provides some comfort, I hope it does. But it also provides, in a sense, reinforcement that those are, in a sense, important targets to aim for, 2 degrees. It's not about 2 degrees versus 2.001. It's roughly speaking 2 degrees that we got to sort of fit in there. The last bit on tipping points is I actually don't use that language myself, and the reason is because when I first talked with people about this, the sort of psychological emotional feedback they gave me in terms of that word was tipping point is irreversible. So you go over it and you've lost power. There's no way to go back. And so you become a victim and you're completely disempowered and there's no options for you. Whereas in fact my view is there will be options when, even if we trigger bad feedbacks, there's still options we can do. And so I tend to use language which empowers people and it doesn't block off people and force them into that victim's sort of mentality.
More questions? Yes.
Yes, thank you very much, Professor Howden. That was a great talk. Look, just on going back right to the start to carbon dioxide being a greenhouse gas, and a lot of people claim that water vapour is a greenhouse gas. Could you just explain how they both work?
Yeah, sure. So you're right. So water vapour is the single biggest greenhouse gas on Earth, but it was there before humans were around. It'll be there after we've gone, and so it's not a human-induced greenhouse gas. Whereas carbon dioxide, where we dig up carbon from underground, we put in the atmosphere, is due to human activity. So the way these work is that direct sunlight, the sunlight we see from the sun, comes in through the atmosphere, and it essentially punches its way through the atmosphere, and it doesn't interact very strongly with water vapour, carbon dioxide, methane, etc., unless the water vapour is condensed and it's in clouds and where you get reflectance. What happens though is that short-wave radiation is absorbed by the Earth and that heats up, and a hot body re-radiates in long-wave radiation. So that's Stefan Boltzmann's law, and so that long-wave radiation then heads out from the Earth towards the space. So as it travels out towards space, because space is a lot colder than we are, and so it's a good place for energy to go, but it may intercept some of those greenhouse gases. So it might be naturally occurring water, or it might be human-induced carbon dioxide. So when it hits one of those molecules, it gets absorbed by that molecule. So shortwave radiation doesn't get absorbed, but longwave radiation does. And that molecule re-radiates, wobbles, it vibrates with extra energy, and it re-radiates in all directions. So it randomly re-radiates, and some of that comes back down to Earth, and some continues on its way back out to space.
So what's the difference between carbon dioxide and water vapour?
They occupy different parts of the radiation spectrum, but they basically have, a similar effect. So if we didn't have water vapour in the atmosphere, we'd have a snowball Earth. We'd be about minus 15 degrees. So at the moment we're plus 15 degrees, and so on average. So water is a really important greenhouse gas. The thing is, we're adding to that by putting up carbon dioxide, methane, etc. And so that radiation effectively keeps Earth warmer than it otherwise would be. So some of that radiation, which is intercepted by carbon dioxide and methane, gets re-radiated back down to Earth, which warms the Earth again, and then it re-radiates again. And so the more of these greenhouse gases you have in the atmosphere, the more of that radiation gets intercepted and potentially re-radiated back down to Earth. And the common experience of this is really simple. If you go out on a clear night, so when it's a clear sky and it'll be chilly, you go out on a night when there's a light cloud layer and it'll be a lot warmer. And that's simply because that cloud layer is re-radiating some of that heat back to Earth. It's acting as a blanket in the atmosphere. And that's essentially how it works. And there's all sorts of minor details about windows of radiation, so the effect of different gases and things, but basically it's a message of blankets in the atmosphere.
I still don't understand.
Well, we can possibly talk about it later, but I've got to drive home back to Canberra.
Yes, would you like to pose your question?
Yeah, I've got a question, and I'd also like to thank you for your presentation. It was brilliant. I've got a question about communication strategy. So in your institute, I imagine you've got a comms plan and all of that. In your mind, would it be perhaps at least as effective going to schools to talk about climate change rather than to politicians? And I think, well, certainly in this country, politicians aren't necessarily the country's finest, and maybe there's more hope going to younger people who've got their lives in front of them. I noticed Italy, for instance, has just made climate change part of the school curriculum. So have you ever thought about doing that?
Yeah, of course, and I do it. And so, so I talk to lots and lots of people. At the moment, I'm doing 3 presentations a week, and so I so well, they're all different. But often there's slides in common. But I talk to a lot of school kids. So going back a couple of months, I did a webinar which got to 2,500 school kids, and so that's a reasonable reach in my view. And so these are kids that probably would never otherwise get that information. Because stuck on the Twitter and Instagram is that they don't sort of get exposed to this, but so I sort of do make very deliberate efforts to get to groups who otherwise may not be engaged with the topic. Yeah.
Good. We have time for some more questions. Go this one, and then down to this one. So yes, sir.
I've only got one question. It's about the media take sensational parts of this, and they frighten the hell out of people. You get children crying because they get a bird to death or the pit. We're not getting enough information out that's scientifically balanced to people in the public. Whose responsibility is that? You can't hand it to the politicians, can't hand it to the academics. How do we do it in a mature way? There's plenty of transformational things that happen, as you say, but people have got this attitude now, we've got to stop everything. Stop burning coal, stop burning petrol, stop everything. And they don't think of the consequences. They're getting emotional about it.
So
how do we overcome this?
Yeah.
There's plenty of opportunities out there, I'm sure we'll come up with.
Yeah. So thanks for that. As I think I've already flagged in several responses, that I think the choice of language is really important, and driving people down into the depths of despair is not a very constructive sort of activity. And so when I engage with school kids, is that I use different language sets and I use different words than I would for an audience like this. And so I'm very sensitive about issues of mental health and particularly with young people. And I've got friends whose kids are in that, in that sort of boat, that who are really depressed because of concern about climate change. But I've also got friends whose kids are really activist, like leading climate strike, and they're not depressed at all. They're right on top of it. It's the same set of information they get exposed to. There's differences in, perhaps initial exposure in the language or personality and how they respond. But some people, say things like that, and they say, oh, well, we've failed to communicate climate change. I actually dispute that. So if you look at the last Lowy Institute report, which came out a couple of months ago, climate change was ranked as #1 threat in Australia, the first time it was. And if you break down the survey, 60% of respondents said they want more action on climate change, even if it costs them significant money. Another 30% said they want more action on climate change, but slower and steadier and not at great expense. So collectively, that's 90% of the population that's saying, yeah, we want more action on climate change. I don't think that's a failure of communication.
Question, George?
High school geography teacher here. I just want to say we spent a lot of time teaching climate change to students in geography. We started in year 7, we start learning about biomes. We don't label it climate change, we just learn about the systems. We learn about feedback, we learn about how the earth works. And then by the time we get to stage 9 and 10, we start learning about sustainability and how to deal with that. So my question to you is, do you have any resources? Because my students here in Goulburn, we're a rural community, we love looking at how to increase our yields. And they want to know how to do it, and they want to know, what's it going to look like, because we talk about succession planning, that taking over the farm, and they need to know this stuff. So if you've got any resources, I'd love them. If you'd like to know also what we teach in high school, please ask. Thank you.
Thanks for that. So just to support the geography thing, that was when I wrote my first essay on climate change, was geography. And I actually went down and some months ago, and I talked to the South Australian Association of Geography Teachers, etc., and I engage with, so not just the students, but also the teachers and the hierarchy as well. But as you probably know, is that there's a pushback about climate change inclusion in the curriculum in several states, and so it's just not, where it should be. Yeah, that's right. Yeah, but it's I still think the fact that we're sort of disguising sends a message in its own right. So it's the Voldemort thing. If you don't name it, you get a distorted view of what you're dealing with, and so.
It's not do you believe in climate change, it's do you understand climate, and then do you understand change?
Yeah.
And that's
Indeed, and so I applaud you for taking that on, and it's great. In terms of resources, there's a huge amount of resources, but they're actually not collated in that way. But some years ago, I worked with a guy in Queensland, David George, who did collate some of those resources for a stab at inclusion of climate change in the curriculum in Queensland. And I could put you in touch with David if you wanted to.
Can we put another question? Yes.
Two quick observations to the question. Just in response to the question from the front about population, when I was working with Barney Ford at CSIRO Sustainable Ecosystems for postgrad, CSIRO was using the environmental impact formula of population times affluence times technology times organisation. So you could have a high level of population affluence and technology, but if you organised everybody cooperatively into what we now call the sharing economy, car shares, tool shares, more efficient use of housing by people sharing their spare houses, etc., you immediately lower your eco footprint. The other thing is your 15% moisture drop per degree Celsius is quite interesting, because there's a paper out the last couple of weeks that said that for every 1 degree Celsius rise in temperature, we need 15% more moisture for the forest fines and litter not to become more flammable. So we've got 15% decrease, we need 15% more, there's a 30% gap there, therefore we're going to have to deal with more fires. So that's more in the precautionary design. And the final thing is the question. My observation over the last 30 years of being a climate science communicator is that most of the ecological systems and global climate systems we're looking at have either significant or parts of them being non-linear responses, exponential responses, tipping points. And yet the IPPC doesn't seem to handle that well, and that's amplified with the paper that came up this week with Fiona Hibbert and other of your colleagues, where they're now saying that the paleoclimate, the climate way back, led to a 3 metre sea level rise in 100 years. And with the instability we're looking at in the West Antarctic ice sheet at the present moment, where are we heading, and what do we do about it?
Can you encapsulate that answer fairly quickly, please?
Yeah, it's first point. How we do things matters. It's just not just how many people, but it's all of those other things you mentioned, and that's part of that story that I was trying to tell. It's if we're smart about these things, we can actually achieve multiple goals at once, and live better lives, and as well avoid climate change. But it's not by doing what we're doing now, and so it does require change, and that change requires debate, and it requires effective listening by different parties, and that's where the lobby group and others have a role to play, I think, in getting those conversations happening. So lots of other stuff that you talked about. The IPCC essentially just compiles and synthesises the literature. If there's information in the literature that's solid and robust, then that will be represented if the IPCC is working well. Yeah, and I've got some sympathy for that, and I've been a little concerned about the sea level rise estimates for some time, partly because of that sort of self-censorship. And I know the paper you're talking about with James Hansen, who set up it could be up to several metres sea level rise by the end of the century, and that was based on particular paleo occurrences, and that is. There's differences of opinion, legitimate differences of opinion as to whether that's realistic, but I think there are issues in terms of methodological preference being used within the IPCC in that domain as well as others, which do tend to reduce the risk rather than portray the full range of perspectives on it. And look, I'm not going to say that, but I think what you do is if you actually look at the trajectory of information and knowledge change in the science, then that does give you a perspective of that you may end up with that conclusion. And so I mentioned that explicitly when I talked about the burning embers and how essentially the colours had migrated down those burning embers over a period of time as our understanding was enhanced. But all of those things, essentially need to be worked through in a fairly thorough and responsible way, and so that's what the IPCC is there to do. But at the same time, it's very dependent on who you get in the specific writing teams as to just how that's done, and so none of these things is perfect. All we can do is try to do a good job, and I think we do a good job.
I think we'd like to ask a question, please.
So my question's just about the ocean acidification.
Can't hear.
My question's about the ocean acidification, and I have concerns there about how with the acidification and the potential dieback of the oxygen producers in the ocean that may have other implications. You've been able to give us some hope around land-based responses, which was good to hear about. Is there any hope on the horizon around the ocean, which seems to be quite a big concern?
Yeah. Well, thanks. It was Elise, wasn't it?
Georgina.
Georgina.
Okay.
Yeah. Right. I was just thinking, what's the probability of having two Elises in my line of sight in one place? So there's a whole recent IPCC report, the Oceans and Biosphere report, and frankly, for me, that makes pretty grim reading. Like it is a pretty grim story from pretty much front to back, and amongst the stories there are what's already happening in terms of acidification. So it's actually it's what's happening is the ocean is going from alkaline to slightly less alkaline. So it's not as though it's acid, it's just less alkaline than it was. So the pH is dropping. And that's already happening, and it's quite demonstrable that's happening. It's already having effects, so particularly in the Southern Ocean, you've got a whole stack of little organisms, that shell-forming organisms that can no longer form shells because the combination of temperature and pH is such that chemical process doesn't happen any further. And we've already started to see decreases in oxygen content, and that report basically said that the future projections of these were quite severe. So both the reductions in oxygen and also the reductions in pH are likely to have quite major effects over large areas. And that pH effect sort of spreads from the cold to the hot, you know, over time, sort of thing. So, you know, this is added to existing pressures on things like tropical coral reefs, which are you know, under extreme pressure right now, not just from climate change but from other things. And so it's painting a picture pretty consistently of you know, higher risk across a whole range of different domains. And so, and unfortunately, oceans being the way they are, there's not that many things we can do apart from just reduce our greenhouse gas emissions. You know, there's things in various locations we can do to just take the edge off the change, but at large scale it's very difficult because they're such big and open systems that, you know, you can't constrain it, you can't manage little parts of it.
I'm not sure the word is enjoyed, but I have been educated and enlightened. But I'm so pleased that halfway through we got to the point where we started to look at how are we going to manage, and it is a possibility, hopefully a good one, that we will get through as long as we start making changes. And that, as you alluded to a few times, is getting together as groups and letting people know how we're feeling. Would you please thank Mark for his time tonight.